Okay, so in this video, we're going to explore a very important algorithm called the Diffie-Hellman key exchange. Now, this key exchange is used as a way to share a symmetric key between two parties over an insecure channel, right? So this protocol is used in things like TLS, SSH, IPsec, and the problem here is how do you get, if you want to use a symmetric algorithm, symmetric key algorithm to encrypt files, how do you get the symmetric key from one side to the other? Because you both have to have the same key for both encryption and decryption. So without actually sharing the key over a public channel, and then the key would be intercepted and stolen, right? So Diffie-Hellman solves that problem. So what you have to do first is I'm going to show you this example here. This example is used very often where they show like the mixing of paints or mixing of colored waters. And then I'll show you another one that's more mathematical. So here we have two parties that want to exchange a secret key that they can use for encryption and decryption. So here we have Alice, and they both have a common color. They have yellow. And Bob also has the same color as yellow. Right, so this you could think of as the public parameters, and these public parameters are going to be shared between the two, and they're going to be the same. So that's why they both have yellow. Then Alice and Bob have their own private key. In this case, the second color, which Alice is orange and Bob is kind of like a turquoise. And then what's going to happen is we're going to get the parameter, the yellows, and we're going to mix them together. So Alice is going to mix her yellow with orange, and Bob's going to mix his yellow with turquoise. And the orange and the turquoise colors, it's a secret colors, so they're not exchanged with each other. So then when you get the mixture, you end up here with like a tan color, and the other one you end up with a like bluish color. So now that the colors are mixed, there's no way of really figuring out, well, how did they get that color? What did they mix to get that? So they can exchange those two colors. So they exchange them. So now Bob has the tan color, Alice has that bluish color. And then what they'll do is they'll mix their secret colors one more time, and then they'll end up both with the same secret color. So it's like a brownish color. So they were able to derive that brownish color without actually exchanging that color between themselves. So that's just kind of one way of imagining it. There's another way here. So this is another example from a website called practicalnetworking.net. Now this one is a little bit more like what we're going to be doing in our lab. So here it's kind of like those yellow colors. They agree on a prime number and a generator of P. So they kind of agree on two different numbers. A prime number, which in this case is very small, because then you can use that prime number and you can use the G number to verify the calculations that are here, right? So the other one is more for those that don't like math, and then this is more of the math interpretation of the algorithm. So they both have their private key, right? They have 5 and 4 here, and then they mix the numbers together, right? So and they both generate their private key, and then from here they do the calculation, they generate their public key, and then they exchange the public keys with each other, right? They don't exchange the private ones, they exchange the public ones. And then once they have that public key, then they will calculate their shared secret, and they both calculate the same value here. And now they have a symmetric key that was not exchanged. So that's kind of the idea for Diffie-Hellman. So I know these diagrams, they may not make too much sense at this point, but we're going to go through the lab, and then hopefully by the end of the lab, you'll come back, you look at these diagrams, and it's like, okay, now that makes more sense. Okay, so for our lab assignment, we're going to be running Kali Linux and Parrot OS. Kali Linux will be Alice, and ParrotOS will be Bob. So first thing we'll do is we'll generate the shared parameters. So we'll generate the shared parameters on Kali, and then I'll go ahead and exchange them with Bob. Then after we've exchanged parameters, then both Alice and Bob will generate their public and private key pairs. Okay, so they'll generate those. And then on step 3, Alice will share her public key with Bob, and Bob will share his public key with Alice. And then once they've done that exchange, then Alice will calculate a shared secret key, and Bob will calculate a shared secret key using Alice's public key. And then we'll compare the two shared keys that they both calculate, and we'll see that they're exactly the same. And then after that, then we'll test the shared secret key. We'll test it by both encrypting and decrypting a file. So we'll create a file on Alice's side. We'll encrypt it using that shared secret. Then I will transfer the encrypted file over to Bob, and then he'll use his shared secret to decrypt it. Okay, so with that, let's go ahead and get started. Okay, so in this video, we're going to practice using the Diffie-Hellman key exchange algorithm, and we're going to practice it using the OpenSSL utility. So here I have Kali Linux open on one side, and I have ParrotOS open on the other. So we're going to use both machines to exchange an encrypted message, and we're going to use the Diffie-Hellman key exchange algorithm so that we can generate symmetric keys that are unique but without actually sharing the key. All right, so let me go ahead. So I'm here in Kali. So first thing I want to do is I just want to check my IP addresses because we're going to have to exchange information back and forth between the two devices. So here I have my IP address of 192.168.1.101. So that's good. Now let me do if config here. Okay, and then this is 102. Perfect. All right, so let me go and open a new tab. I'll leave that information there because we'll need to refer to it back and forth as we exchange information between the two machines. All right. And if you just want to verify, you can ping. So I'm going to go ahead and just ping here 192.168.1.102. So I'm pinging the ParrotOS machine. It's working fine. So we're good. Okay. And then here I'll go ahead and clear as well. Oh, I needed that actually. So if config. There you go. If config. All right. Okay, so here in the terminal, what I'm going to do is I'm going to go to my documents folder so I can save all my files in one place. So I'm going to documents here in Kali. And then here I may have several things here. So what I'm going to do is I'm going to create a new directory. So I'm going to do mkdir, and I'm going to call it dh. Okay, and then I'm going to enter that folder. So I'm going to do cd dh. And then clear. So now I'm in the dh folder. I'm going to do the same thing here for Parrot. So cd documents, and then mkdir dh, and cd dh. Clear. All right. So I have two folders now on each machine that are the same. So that's good. First thing I'm going to do is I'm going to use Kali, and I'm going to generate the parameters. So those parameters have to be shared between the two machines because those parameters will be used to generate the keys. Okay, so for that, you're going to do open SSL, and then gen p key, and then dash gen param for generate parameters. And then which algorithm are we going to use? So algorithm, so ALGORITHM algorithm. That's going to be DH for Diffie-Hellman, and then dash out. And then we're going to call this parameter PG. Parameters PG. PG.pem. Okay. Now go ahead and press enter. So it's generating those parameters. And then, all right, so that's done. So go ahead and clear, do ls. So I have my file here, parameters pg.pem. Okay, and then you can verify, you can look at the parameters. So I'm going to do open SSL, and then pkey param dash in, and then parameters pg.pem, and then dash text. So this will be more human readable, so we can see how it looks. All right, so here's P, the very long number, and then here's G. So now this, we need to provide this information, we need to transfer it over to Parrot OS. So we both have to have the same parameters. All right, and these can be transferred unencrypted. This can be sent over. It doesn't matter, because even if this information is intercepted, without the private keys, there's really not much you can do with this. Okay, so to transfer it over, I'm going to go ahead and hit clear. I'm going to create a web server. So Python 3 -m http.server, and then 8080 is the port. Okay, so now I'm running my web server. Now here, I have to get those parameters, because I'm going to need to use those. So let me go ahead and do wget http ://192.168.1, and then make sure I have the right IP address. Yes, 101.8080, and then the file I need is going to be parameters pg.pem. Okay, and if everything's okay, you should have gotten a message here that showed that you downloaded that file. Do ls, and then now we have the file here, and we were able to exchange those parameters successfully. Okay, so I'm going to go ahead and shut off the web server here. So I did Control-C on the Kali Linux side. I'm going to hit clear. Okay, and then here I can clear this out as well. All right. Okay, so the next thing we're going to do is, using those parameters, we're going to generate a public and private key pair, one for, so this side is going to be Alice, this side is going to be Bob. All right, so Alice is Kali, Bob is Parrot. So for Alice, let's go ahead and generate a public private key pair. So I'm going to do open SSL, and then I'm going to do gen p key, and then param file, and then I'm going to get my parameter file. So I'm just going to press tab, and then I'm going to do out. So it's going to generate my public private key pair together in one file. So it's going to be Alice public private key pair .pem. Okay, and then press enter. So there's no typos or anything. You shouldn't see any output. But if you do ls, you'll notice your file is here. And then if you want to verify and look at the file, you can do that. So you can do open SSL, and then p key -in, and then Alice public private key pair .pem .text -no out. Okay, so this will show you what the file looks like, and it's more readable, human readable. So here it shows the private key, which you definitely don't want to show anyone. Of course, this is just an example, so it doesn't matter. Okay, this is the public key. This can be shared. So we're actually going to to pull the public key out of this file and then exchange that with Bob eventually. Okay. But of course, you're not supposed to show the private key, but this is just an example. So let me go ahead and clear. Now I'm going to go here. I'm going to do the same thing with Bob. So it's going to be open SSL p key dash in. I'm sorry, wrong one. It's open SSL gen p key dash param file, and then parameters pg. So we have the same file, so I'm just going to press tab and then dash out, and then I'm going to do Bob public private key pair dot pem. Okay, so now if I do ls, I should have two files: my parameter file, and then I have my public private key pair. All right, so now I have my own public private key pair. This I don't want to share with anyone, and Alice has that as well. Okay, so the next thing we're going to do is we need the public key. So from that key pair, I need the public key. So we can extract that. So I'm going to do open SSL, and that's going to be p key, and then in dash in, and that's going to be Alice public private key pair dot pem, and then pub out for public out, pub out, and then dash out, and that's going to be Alice public key dot pem. Okay, so I know it's a little weird because it's cut off, but just keep typing, you'll be fine. So Alice public key. So press enter. So now we should have three files. We should have Alice public key, Alice public private key pair, and parameters PG. So the next thing is for us to share this file with Bob. But before we do that, let's generate the public key for Bob as well. So we'll use the same command. So we'll do open SSL p key dash in, and that's going to be Bob public private key pair dot pem dash pub out, and then dash out. We'll call it Bob public key dot pem. Okay, so then go ahead and press enter. There's no errors. Do ls. We should have three files as well. We can view the contents of Bob's public key. So we'll do open SSL p key dash in. I'm sorry, dash pub in dash in, and then we'll do Bob public key dot pem, and then dash text. All right, so you can see all the information here, the prime number, the generator, what was used for all this, and then here's the public key. So this is how it looks. Okay. So everything's working good so far. Now what we're going to do is we need to exchange the public keys between both parties. Okay. So we can start with Alice, and what I'm going to do is I'm going to run the Python server. So it's already codes here. So I'm going to run the Python server, web server here on port 80. And then on this side, I'm going to download the public key from Alice. So to do that, I'm going to do wget HTTP :// 192.168.1.101 port 80, and then / I'm going to do Alice public key.pem. I'm going to press enter. So now I downloaded the public key from Alice. So now I have her public key. I don't have her private key. I just have her public key. Okay. And then I'm going to go here. I'm going to do Control-C. So I turned off the web server on this side. And then here I'm going to hit clear. Now I'm going to run the web server off of Bob so I can transfer the public key to Alice, Bob's public key. So then from here, I'll do Python 3-m http.server, and then I'll do 8080. Okay, so now I'm running the web server here off of Bob. So let me go ahead and get the public key. So then from here, I'll do wget, and then I need the IP address. Okay, so it's .102. So I'm going to do HTTP :/ 192.168.1.102, and then / Bob public key.pem. I'll press enter. Oh, I forgot the port number. So if you see that error, you know why. So that's 8080. All right, there you go. So I was able to download that file. So ls now, and now I should have Bob's public key. And then here I'm going to cancel. I'm going to do ls, and I should have Alice's public key. Yeah. All right. So we've successfully exchanged public keys. Okay, so I'm going to hit clear here, and I'm going to hit clear there. All right, so the next thing we need to do is we need to derive the shared secret key. All right, so this is the symmetric key that we're both going to have, but we're going to have it without exchanging them. So here on Alice's side, I'm going to do open SSL p key util. That's p key utl, and then dash derive, and then dash in key. And then I'm going to use Alice public private key pair .pem, and then dash peer key, and then I'm going to use this Bob's public key. So Bob public key .pem, and then dash out. This is going to be Alice shared secret .bin. Okay. So then press enter, do ls. So now I have Alice shared secret bin. And then I'm going to do the same thing on Bob's, but I need to verify that these two keys just to show you that they're exactly the same. So what I'm going to do is I'm going to go ahead and calculate MD5 sum. I'm going to calculate the MD5 hash on this file. So MD5 sum, and then I'm going to do Alice shared secret.bin. Okay, and that's going to give me this particular hash here. Now I'm going to do the same thing on Bob's side but instead of using Bob's public key, I'm going to use Alice's public key, and it's going to generate his own key, but the key is going to be exactly the same, and we'll verify that using MD5 sum. So then let's go here, and then I'm going to do open SSL key util dash derive dash in key, and this will be Bob public private key pair dot pem, and then dash peer key, and then here instead of Bob I'm going to use Alice's public key, Alice public key dot pem, and then dash out, and that will be Bob shared secret dot bin. So press enter and do ls. Now I have Bob shared secret dot bin here. All right, and then I'm going to verify the hash to see if they're the same file. So md5 sum, and then Bob shared secret dot bin. Press enter, and we can verify the first 4 digits are the same. These other digits here are the same as well. So these are the exact same keys, and we've generated those keys without actually having to share them. So now we can use them. We can use that key for both encryption and decryption. So that's what we're going to do next. Okay, so let me go ahead and clear this real quick. And then I'm going to create a message. So let me do echo. And then I can do in quotes, hello, this is a secret message. Okay, single quotes. And then we'll do greater than, and then I'm going to call it plain for plain text. Okay, and then do ls. I should have a file called plain. Do cat plain.txt. All right. So now I have my plain text message. Now I'm going to use my new key to encrypt it. So for this, you're going to have to use the OpenSSL command. OpenSSL, this one's going to be a little long. So this is going to be ENC-AES-256-CTR, and then -PBK-DF2, and then -E for encrypt, and then -A, and then the in file is going to be plain.txt, and then the out is going to be encrypted.txt. So just keep typing even if it runs into the next line. And then -PASS. And then here we're going to use a file. So now this file is going to be our key, which is going to be Alice shared secret.bin. Okay, so then press enter. If we didn't make any typos, everything should be good. Do ls. Now we should have an encrypted.txt file. I can do cat encrypted.txt. So there's our encrypted file now. Now what we want to do is we want to transfer this encrypted file. We want to transfer it over to Bob, see if Bob can decrypt it using his shared secret. So let me go ahead and run the Python server. So python 3-m.http.server.80. So then press enter. Now I'm going to come here. I'm going to hit clear on that. I'm going to do wget http://192.168.1.101 port 8080, and then here I'm going to do /encrypted. Make sure you spell it right. .txt. So I was able to download that file. I can go ahead and cancel the web server here on this side. Hit clear here. All right. Now, let me do ls. I should have my encrypted.txt file here. So now I'm going to run the same command again, but this time to decrypt. So I'm going to do open SSL and then ENC dash AES dash 256 dash CTR dash PBKDF2 and then dash D for decode. The last time we did it with encode or encrypt. Now it's decrypt. So dash D dash A, and then the in file, instead of it being plain.txt, it's going to be encrypted.txt. And then our out file this time is going to be the plain text. So plain.txt and then dash PASS. And then here we're going to have the file, and instead of using Alice's shared secret, we're going to use Bob's shared secret, which are the same file. Shared secret dot bin. And press enter. If everything's okay, you won't see anything. But if we do ls, we have a plain text now. So now let's take a look. So cat plain.txt, and you notice now that is our secret message, and we're able to decrypt it using a symmetric key that we did not share with each other. I want to thank you for watching this video. That's going to be it for this lab, and I'll see you in the next one. Thank you very much.